All right, here's the video for Monday. I think it's April 26th, I believe. Anyway, this is the division of fractions. This is just the warm-up here. Pause the video and try these problems on your own first, and then come back and check your answers on here. So, all right. To do this one, this is a parallelogram. The area of any parallelogram is base times height. And so the base is 2.5. I don't know what happened there. Base equals 2.5 meters, and the height equals 1.8 meters, right? And what we'll do then is we will multiply them. The 2 in this case would be used for perimeter, but for now, I guess it's a distractor, right? So 2.5 times 1.8. I will do the 2.5 times 1.8 here. And we're just, there we go, 0.54. And then now I look at it and I say, oh, that, remember, is this one's in 25 tenths. This is 18 tenths. So my answer has to be in the hundredths. So hundredths tenths, 4.5. 4.5 will be my answer for that one. So area equals 2.5 times 1.8 for an answer of 4.5 square meters. This triangle, again, pause and give that a try. This triangle, area of any triangle, is base times height divided by 2. In this case, the base is 0.6 meters, and I know that it doesn't have the right angle in here, but I think we can assume that because we have no other values indicating a height in here. So that'll be our height of 0.4 meters. We should be pretty proficient at multiplying our decimals here. If we go through kind of that sprint part that we did before, we just do 6 times 4. 6 times 4, which is 24. But then we have to look at it as in, again, this one is the tenths place. This one is in the tens place, and my answer has to be in the hundredths place. So that's hundredths, tenths, 24 hundredths. So I slip a 0 in there. So this is 24 square meters for the, whoops, I did forget something, didn't I? I also forgot to divide by 2, right? What's half of 0.24? Oh, that one works out kind of slick today. Half of 24 is 12, so 12 square meters. If you were thinking, man, I didn't see that, Mr. Crone, you know what? You could, what in the world? You could do it separately, and you would still get that, right? Here we go. All right, last but not least, I'm going to zoom in a little bit to help me distinguish this trapezoid. Remember, it's the area of 2 triangles. One of these triangles, we got to split that into those 2 triangles. There's one, and we could focus in on this bottom triangle as our blue one, and the top one as the red one, right? And if we focus just on that red one, area equals that base times height divided by 2. Base in this triangle is 2.5. Height will be also 5 here. So base is 2.5 centimeters, and height is 5 centimeters. And so we need to multiply 5 times 2.5. That one, we'll just do that on that side here. 2.5 times 5. 5, carry the 2, that's 12. So we look, and this is the tenths times something that's in the ones place, so we have 10. So we need that in the tenths place, so that means that's going to be 12.5. So area equals 12.5, and we got to divide that by 2. Now I could see that half of 12 is 6, and half of 0.5 is 0.25. Square centimeters, but maybe you didn't see that, and so we could do some of that here up on the side. 2 into 12.5, and I might need some zeros, so I'll just put some zeros in there. How many 2's into 1? None. How many 2's into 12? 6. 0, drop my 5 down. How many 2's into 5? 2 of them. I'm going to have to drop a 0 down. How many 10's into 2? How many 2's into 10? Sorry, that's a 5. There's that 10, 0. That's what I'm looking for, right? Okay, so that's that 6.25 that I was just showing here. All right, let's focus now on that blue triangle, right? The area of any of that blue triangle, or any triangle, I'm sorry, is base times height, and divide that by 2. And its base is that 6 centimeters. Oops, sorry, 6 centimeters. And the height is the same, right? And the height is 5 centimeters. Just as a quick recap, the two lines that are parallel to each other, that's this line and this line, are the bases of the trapezoid. They are also going to be the bases of the two triangles, and the height of the trapezoid is also the height of both triangles. Okay. All right, so base times height, that's 5 times 6, which is 30. So the area equals 5 times 6, or 30, divided by 2. That's 15 square centimeters. So we put, to find the grand total, we just add our 2 together here. Make sure that we line up place values, right? Place values, and by doing that, we also line up our decimal points, right? It's place values that we're really lining up. Decimal points turn out to be the indicator to help everybody out here. So 21.25 square centimeters, and that's our area for this. Today, our in-class work's going to be around here. If you're in class, you'll be just doing one of these at a time. You're going to bring it up, check it over, check it off with me, and then I'll give you the next one to go through. I'm going to try to go through maybe 3 or 4 of these just to give you at home just a note about how to do that, and then you can come in and just check this. I'm not going to leave an answer key. Just check and get kind of part of that. If you still have more questions, let me know. So for this one, a baker's making donuts. He has 11 pounds of dough. Each donut is made from 1/8 pound of dough. How many donuts can he make? Let's draw a representation. So we have to draw our 11 pounds of dough, right? Let me see what would be a good way to do it. Let's do that in circles. And what I'm going to do is I'm going to do one of them and repeat it. And we need 1/8 of a pound of dough. So if that's 1 pound, I need to divide that into 8 pieces. And once I divide that into 8 pieces, right, it allows me just to here duplicate this. So hopefully these all fit. And let's get 8 of them now. And I'm running out of room, huh? I'm going to put them down here, even though I know I need them up there. So that is 8, 9, 10, and 11. Whoops, that's not what I wanted. And here we go. We'll slide those up there, right? So there's that diagram to represent that. Because we are looking at 1/8, and this is important kind of on the fraction stuff that we were dealing with, right? We are looking for how many 1/8 pieces do we have in there, right? And I could count them 1, 2, 3, 4, 5, 6, 7, 8. But we know we're going to have 8 per thing, and we have a grand total of 11 of them. So we can just simply take and excuse me, do that 8 times 11. So let's write that number sentence to represent this situation here. And that number sentence would be, we have 11 pounds. Whoops, I don't want to use that one. We have 11 pounds. We need to divide them into 1/8 pieces for a grand total of 88 donuts, right? 88 donuts. The multiplication sentence looks like 11 times 8 equals 88. Okay? All right, so this one's going to be a little different because we can see that the fraction here is going to be 2/3. All right, so let's go through this one. The local soup kitchen is serving soup for dinner. The cook has made 12 pots of soup, and the helpers are putting 2/3 of a cup of soup in each bowl. How many bowls of soup can the helpers serve for dinner? So we're going to draw that diagram in here. And in here, we could do 12 pots and 2/3. So if I do 12 pots, I'm going to have to draw small. Let's do this as 1 pot, and we're going to do that in 2/3 right there. We need 12 of them, so I'm going to just put that here. That'll be 2, and now all of a sudden I have 4, and now I can make 8, and I'll duplicate this to make a grand total of 12, right? There we go. So 2/3 of a, so 12 pots soup in there, 2/3 of a cup in each bowl. How many bowls of soup can helpers serve? I'm assuming 12 pots would be 1 cup. That is a good question, actually. I'm going to have to assume that, right? That each pot is a cup, but that doesn't sound right. Well, we're going to have to go with it. So we're going to have to put these into 2/3. So in that 2/3, you know what I'm going to do? I'm going to break them into this. So here we go. We have 1/3, 2/3. So that's 1, right? That's the first pot. And then I'm going to just go in order here. Orange we'll go with, right? And I know it's going to take a little bit, 1/3 and another 1/3, right? So for this one's pot number 2. And then let's go to, we'll skip yellow because yellow's hard to see. Let's move to a green. And green. And so that's another 2. And that's going to be 3. And then we'll go with blue for 4. And then hopefully now we've got that everybody's in 2/3. So what I'm going to do is I'm going to switch over now and just use black. So 4, that's going to be number 5. That one's going to be number 6. This one's going to be number 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. All right, let's put that all together down here. What's that number sentence look like? 12 divided by 2/3 is going to be 18. Now, that's good enough for me, and you do not have to have any more, but if by chance you recognize that it's going to be 12 times that 3 divided by 2, we would get, keep in mind that's going to be 12 over 1 times 3 over 2, which is 12 times 3 over 2, and that equals 36 halves, which is 18, okay? All right, last one I think I'm going to do today. Let me see if, let's go to, I was just going to try something a little different on this one. Let's try this last one, this pizza problem here. Okay, so we have 9 pizzas, and each friend wants to eat 3/4 of a pizza, right? So we have those 9 pizzas. Let's draw those 9 pizzas here. 1, and I'm going to break them into fourths, right? Because they're in fourths, and then we'll have to break them into groups of 3 after that, right? So 1, 2, and then we'll need 9. So we'll duplicate that. And we'll duplicate again. I didn't leave good spacing on this. How many do I have here? 2, 4, 6, 8, and 1 more, And there we go. I think we got 9. And so now we need to break them into 3/4 of a piece of pizza. So I'm going to circle them in those groups of 3/4. That is 1. And then we got 1. And I'm intentionally using the same color because that's what you guys would have if you were doing this on your own. There's number 3, 4, 5, 6. That was not a very good job of placing that. 7, 8, 9, 10, 11, and last but not least, 12. Let's see how that stacks up here. Number sentence. We started with 9 pizzas, and we divided them into 2/3, and our answer is 12. That's good enough for me. Again, I'm going to reemphasize you do not have to have anything more than that right now for stuff that we're focusing on, but it is 9 times the denominator of 3, but we'll have to divide it by the numerator, and that equals 9 times 3. Remember, this is over 1. 9 times 3 over 1 times 2, which equals 27 over 2. Wait a second. Did I mess something up? Oh, that's because it's not thirds, it's 3/4, Mr. Crone. 3/4. And that, yes, Mr. Crone, you did mess that up. 3/4. 4 over 3. 9 times 4 over 3. That's 36 over 3. And that is 12. There we go. Feeds 12 people. So let's, again, just kind of reiterate what happened to help focus on our thing. We have 9 pizzas, right? And they are divided into quarters. But each person's going to eat 3 of those quarters. Right? And that means that we can feed a grand total of 12 people. Okay, if you have any other questions, let me know.